Derivation of formulas for compound angles. In this video, we'll discuss for two angles when we form a compound angle a minus b and a plus b are the compound angles. So we're looking to the formulas of cos and sine, like cos a minus b, cos a plus b, sine a minus b, and sine a plus b. We'll start with proof for cos a minus b, which is nothing but cos a cos b plus sine a sine b. To prove this, first we will consider the coordinate plane x and y axis. In this, with origin as center, we draw a unit circle. Unit circle means radius is 1 unit. So if we take any point on the circle, from the center, it will have 1 unit. So let us consider a point along the positive x-axis. Let it be P. And then the coordinates of P would be 1, comma 0. As on x-axis, y value would be 0. And this is a unit circle, so x value would be 1. Now consider another point P1 on this circle such that it makes an angle A. Now how to derive coordinates for this point P1? When we look into this picture, here we have 180 minus A as the angle with negative x-axis. So when we draw a perpendicular from here, this is the x value and this vertical one is a y. This x shows the adjacent side for which the formula would be cos of 180 minus x. Cos 180 minus x is minus cos x. As it is the negative x-axis, we will have this minus sign. Here it is a, so 180 minus a. This is cos a. Similarly, the vertical one is the opposite side for the angle. For the opposite, we'll have sine 180 minus a. You know this formula that sine theta is equal to opposite by hypotenuse. But here the hypotenuse OP1 is 1 unit. So we can just keep 1 in this hypotenuse place. In that case, we'll get sine theta is equal to opposite side. Whereas theta here is 180 minus a here. So 180 minus a is nothing but sine a. In second quadrant, sine is positive. So we'll just have sine a. So this value of y is sine a, because of which we can write first x value, that is cos a, and then the y value sine a. As it is in the second quadrant, the x will have the negative sign. Ignoring the sign here and considering only the value, so we'll write cos a here. Ordinates for P1, that is cos A, comma sin A. Consider another point P2 on the circle such that it makes an angle B with the x-axis. Now to write the coordinates for this P2, B here, so along the x-axis, if we drop a perpendicular from P2 to x-axis, this is the x value, then this would be cos B, and this vertical thing is the y value. As it is opposite side, it would be sin B. So P2 will have values of cos B, comma sin B. We know that P2O and P1, that's the angle, and its value would be A minus B because this entire angle is A. From that, we have to subtract this small b so that we will get this angle P2O P1 angle. Then this value will become A minus B here. With this measurement, we will identify a point P3 on the circle such that it makes A minus B angle with the positive x-axis. So let this be a for the coordinates of P3, considering this A minus B value along x-axis, it would be cos A minus B, and this perpendicular value for the y value, it would be opposite side. So sine of A minus B would be the value for y coordinate. We'll write the coordinates here. The construction of circle is done. We can see two A minus B values. One is made by P0 and P3. P0 O P3 is A minus B, and the second angle is P1 O P2. That is the second A minus B angle. In a circle, we know that when any 2 points on the circle are joined by a straight line, it forms a chord. And if two chords make equal angle at the center of the circle, then both the chords would be of same length. Using that concept, here we can tell that chord PO and P3 will be of same length as chord P1, P2. This point we will take as a starting point for the proof. In coordinate geometry, to find the distance between 2 points where x1, y1 is 1 point and x2, y2 is the second point, we have a formula like under root x2 minus x1 whole square plus y2 minus y1 whole square. This gives the distance between 2 points. Now we will use this formula to find the length of chord PO P3 and chord P1 P2. For the length of chord P0 P3, consider this to be x1 y1 and the second one to be x2 y2. From the formula under root x2 minus x1 whole square, in place of x2 we have cos of a minus b, and for x1 it is 1, so minus 1 whole square plus y2 minus y1 whole square. Y2 is sine of a minus b and y1 is 0, so minus 0 whole square. For the length of P2 P1 chord, again we'll do the same thing. The first one is x1 y1 and the second one is x2 y2. So x2 minus x1 whole square means cos A minus cos B whole square plus y2 minus y1 whole square, that is sine A minus sine B whole square. Square the entire equation, then the roots can be cancelled out. The first one is like x minus y whole square. X minus y whole square is nothing but x square minus 2xy plus y square. In place of x, we have cos of a minus b. So cos square a minus b minus 2xy means minus 2 cos a minus b into 1 plus y square, that is 1 square. Then we have here minus 0, we can ignore that. So sine of a minus b whole square can be written as sine square a minus b. Cos square a minus b plus sine square a minus b can be written as 1. And the 1 here we have, so plus 1 again. This entire term s is minus 2 cos of a minus b. This side also will try to expand these two terms, that gives cos square a minus 2 cos a cos b plus cos square b. For the second term, it is plus sine square a minus 2 sine a sine b plus sine square b. Now again here, cos square a sine square a can be written as 1. And again cos square b sine square b can be written as another 1. And the remaining terms, that is minus 2 cos a cos b, and this term minus 2 sine a sine b. Here 1 plus 1 is 2 minus 2 cos of a minus b. Take 2 outside, that makes 1 minus cos of a minus b. On the other side also 1 plus 1 is 2 minus the entire term here cos a cos b minus 2 sin a sin b. From this also we will try to take 2 out. So that makes 2 of 1 minus cos a cos b minus sin a sin b. Now divide the entire equation with 2. When we divide it with 2, both the 2's will get cancelled out. That leaves 1 minus cos of a minus b is equal to 1 minus cos of a cos b minus sin a sin b. We'll try to subtract 1 from the both sides. So when we do minus 1 on both sides, the ones will get cancelled out. And here also, remaining value is minus cos of a minus b is equal to minus cos A cos B minus sin A sin B. Now from here if we take minus out, that gives cos A cos B plus sin A sin B. Now this entire equation can be multiplied with minus 1. If we do multiplication with minus 1, the final value would be cos of A minus B is equal to cos A cos B plus sin A sin B. So this is the final formula for cos of A minus B. For cos it x plus y. So x plus y, the place can be written as minus into minus. So this can be written as cos of x minus of minus y. When we compare with the formula here, in place of A we have x and in place of B we have minus y. So just substitute the values. In place of A here it's x. Cos B means in place of B we have minus y. Again plus sin A. In place of A again x. Sin B. In place of B we have minus y. From the formula cos of minus theta is equal to cos theta, this becomes cos y, and sin of minus theta is equal to minus sin theta, this value becomes minus sin y. So this can be written as cos x, the entire term we are writing here, cos y, and this second term will become plus sin x into minus sin y. This is sin x into minus sin y. Minus into plus is minus. This can be written as cos x cos y minus sin x sin y. This is the required formula that can be used for cos of x plus y. And the next one is proof for sin of x minus y. For this sin of x minus y value, we will try to use cos A plus B formula. Now, sin and cos are co-functions, which means sin theta can be written as cos of 90 minus theta. Here in place of theta, we have x minus y. So, we'll write cos of 90 minus x minus y. This will become now, take the minus inside, cos 90 minus x, minus into minus is plus y. From this entire thing, this 90 minus x will be considered as A and y will be considered as B, and keep the values in this formula for cos of A plus B. If we substitute, it becomes cos A. Cos A means cos of 90 minus x. Cos B means in place of B we have y, so cos y, minus sin A. So in place of A 90 minus x, sin B, in place of B we have y. Cos of 90 minus x is nothing but sin x. The cos y as it is we will write, then we have minus. Here sin of 90 minus x is cos x. So cos x sin y. This is the formula for sin of x minus y. In a similar manner, we will try to prove for sin of x plus y. To prove that, we will consider sin of A minus B that we have just proved. So sin of x plus y, here in place of x we will write minus into minus. So this makes sin of x minus of minus y. Again here in place of A we have x and in place of B we have minus y. So from the formula, this is the entire thing is like sin A minus B. So we are using this formula now. Sin A, in place of A we have x, cos B, in place of B we have minus y, minus cos, in place of A we have x, sin B, in place of B we have minus y. So now from here sin x, cos of minus theta is cos theta, so cos y here minus cos x, sin of minus theta is minus sin theta, so minus sin y. This first term will write it as it is. Here minus into minus is, here we have 1 minus and again 1 minus here, minus into minus is plus, so plus cos x sin y. This gives the formula for sin of x plus y.